Hi students, today in this video we are going to discuss how to solve the graph related problems from the gaseous state. Okay, from the following plots find the correct option. Now the plot is, it is pressure versus volume and it is a straight lines. T1, T2 and T3. Now the options are T1 greater than T2 greater than T3, T3 greater than T2 greater than T1. C. T1 is equal to T2 is equal to T3. D. None of the above. Okay. Now, when this type of problems are given, what you have to do? How to solve these problems very easily without any error. So first you have to look for what are the variables on the x-axis and y-axis. On x-axis it is volume and on the y-axis it is pressure. Now at a constant temperature, these plots are at a constant temperature. Now you have to recollect what is this law. It is at a constant temperature, the pressure and volumes are variable for a given amount of a gas, then it is Boyle's law. Now write down what is Boyle's law. Here it is pressure which is inversely proportional to volume at a constant temperature for a given amount of a gas. So this is the plot from the Boyle's law. And with this proportionality is replaced by a constant K. Okay. Now this is in the form of y is equal to mx. That's why it is a straight line and the slope is positive. It is the straight line passing through the origin. Okay. Now, what is ideal gas equation? Here, the ideal gas equation is PV. You assume this is the equation 1. Now, what is ideal gas equation? It is PV is equal to nRT. Now, it is P which is inversely proportional to volume. From this you write P. P is equal to, it is nRT into 1 by V. So, let us take this is equation number 2. Okay. Now, from this 1 and 2, what is the value? Here, this nRT. Here, this Boyle's law, number of moles are constant because here we are in the Boyle's law statement itself, for a given amount of a gas means number of moles fixed. R is universal gas constant and T is temperature, and these two, how these 1 and 2 equations are related? If we equate these two, K is equal to nRT. Means here K means slope. Here it is in the form of y is equal to mx. So K is slope and it is proportional to T. Slope is proportional to T. So if the slope is more, means if the slope is more, the value of T is more. Simple. So here more slope, less slope, still less slope. Okay. So what is the relationship between T1, T2 and T3? T1 which is having greater slope, greater the value of T because K is directly proportional to T. So T1 is greater than, T2 is greater than T3. I think option A. Okay. So here I'll revise once. Here first you have to look for the variables. What are the variables on x and y axis? So here pressure and volume relationship at a constant temperature. You have to remember at a constant temperature means temperature is constant throughout the line. That's it. Here this is many of you think that T1 is equal to T2 is equal to T3 will be the right answer. No. Because you are saying, ma'am, it is a Boyle's law. You are saying at a constant temperature, so all the temperatures are equal. No, those are three different plots. And the temperature is constant throughout the single plot. Not T1 is equal to T2. I think you got my point. So just write down the Boyle's law, and from the ideal gas equation you equate these two, and here the slope is directly proportional to T. So T1 is greater than T2 greater than T3. Okay, now we'll solve another problem, then it will be more clear to you. Okay, now we'll solve another problem like this. It is volume versus temperature at a constant pressure. When temperature is constant, we call the plot as isotherm. When pressure is constant, we call it as an isobar. Okay. So now here, now the options are A, P1 greater than P2 greater than P3. B, P3 greater than P2 greater than P1. And C, P1 is equal to P2 is equal to P3. And D, none of the above. Now what I told you while discussing the previous problem, first look for the variables. What are the variables on the x and y axis? And here volume and temperature are variables. It is Charles' law. At a constant pressure. So at a constant pressure, for a given amount of a gas, volume is directly proportional to temperature. So these plots are from Charles' law. Now what we have to write? We have to write the equation, Charles' law equation. Volume is directly proportional to temperature at a constant P and for a given amount of a gas, means N is also constant here. And here the proportionality is replaced by a constant Kt. It is in the form of y is equal to mx. Okay, now what is the slope? It is k. As the slope is positive, it is a straight line passing through origin. Now you assume it as equation 1 and write the ideal gas equation, which is equal to, which is PV is equal to nRT, and here you write the value of T, which is equal to nRT into it is nR by P into T. You assume this as an equation 2. Okay, now if you compare these two equations, what is the value of K? K is equal to nR by P. Now what is the relationship between K and P? If you look this carefully, K is inversely proportional to pressure. That's it. Now more slope, less will be the pressure. Now which is having more pressure? P3, slope is less, pressure is more. So P3 greater than P2 greater than P1. Your option will be P3 greater than P2 greater than P1. Okay, just look for what are the variables on the x and y axis. Write it in the form of y is equal to mx plus c. Y intercept is not there, no? So it is in the form of y is equal to mx. So just compare this with ideal gas. PV is equal to nRT. Now look for how K and P are related. So these are inversely proportional. So more slope, less will be the value of P. Okay. So more slope, less will be the value of P. That's it. Simple. Thank you.